all the roots of the polynomial z to the 6th minus 10z to the 5th plus az to the 4th plus bz cubed plus cz squared plus cz plus 16 are positive integers. Possibly repeat. What is the value of b? First, we notice that from our expression by Vieta's formula, we will first have 6 roots. And we know that the sum of the 6 roots will be equal to, so sum is equal to negative of negative 10 over 1, which is just 10. And then we know the product of the roots will be equal to positive 16 over 1, which is 16. So since we know that the sum of the 6 roots is 10 and the product of the 6 roots is 16, we know that there is only going to be one case of this because they are all positive integers, which is 4 2s and 2 1s. Once we are able to note this as the 4 roots or the 6 roots, we can write out what this would be expanded. It would be z minus 1 times z minus 1 times z minus 2 4 times, which is just z minus 2 to the 4th. So our polynomial is going to be in this form. Let's expand this out slightly. This gives us z squared minus 2z plus 1, and z minus 2 to the 4th will end up giving us z to the 4th minus 8z cubed plus 24z squared minus 32z plus 16 if we use Pascal's triangle or binomial theorem. And then after we get this expansion, we should be able to realize which ones or which terms multiplied together will give us a z cubed term, because if we want the coefficient b, or if we want the value of b, we want the coefficient of all the z cubed terms. So we realize z squared times negative 32z will give us a z cubed term. Negative 2z times 24z squared will also give us a z cubed term. Negative 8z cubed times 1 will also give us a z cubed term. So what is the coefficient of all these terms? Well, that would lead to, first off, negative 32z cubed. And then secondly, we will get negative 48z cubed. And lastly, we have negative 8z cubed. So now that we can add these all up, we get that b is going to be equal to negative 32 minus 48 minus 8, which leads to a final answer of negative 88 as the value of b. And that is answer choice A.